Hello and welcome to Lifecycle Assessment in Practice, Module 1, Course Introduction and Review, Part 1 of a 3-part series covering how lifecycle assessment is utilized as a tool for improved environmental performance in the LEED rating system. My name is Pete Choquette, Principal and Director of Design from Epstein Group in Atlanta, Georgia, and joining me today is Dr. Liz Monet, our office's expert on lifecycle assessment, who is responsible for all of our environmental product declaration and whole building lifecycle assessment projects. Today we will be covering some of the basics of life cycle assessment, or LCA for short, and how it's used in practice. Specifically, our learning objectives are 1. To explain the terminology and the science behind LCAs. 2. To articulate how LCAs and environmental product declarations, or EPDs, may be beneficial for buildings and businesses. 3. To identify the new LEED version 4 credits related to LCA. And 4. To describe the steps to achieve those credits. Let's start with an overview of life cycle assessments and how they are related to the LEED rating system. We're going to be talking about two types of life cycle assessments today, product LCAs and system LCAs. We can visualize a product as a door handle and a system as a building. A product life cycle assessment delves much deeper into the actual impacts of how a material affects the environment than the rudimentary ways that the LEED version 2009 credits, such as the credits for recycled or regional content, did. LCAs incorporate recycled content and often the location within a broader range of factors which we will go into soon, in order to create a more comprehensive picture of the entire environmental impact of that product's lifespan. Whole building life cycle assessments help generate an understanding of a building's lifetime performance as related to the materials chosen. So how exactly are LCAs related to the LEED credits? First, conducting a whole building life cycle assessment makes you eligible to apply for the LEED version 4 Building Life Cycle Impact Reduction credit. This credit was also available in a similar form in LEED version 2009 as Pilot Credit 63, Materials and Resources Whole Building Life Cycle Assessment. Conducting product life cycle assessments can contribute to the LEED version 4 credit Building Product Disclosure and Optimization Environmental Product Declarations. And because LCAs involve collecting background data on the materials used in a project, achievement of two other credits may be assisted by them: the Building Product Disclosure and Optimization credits for sourcing of raw materials and the credit for material ingredients. This course is focused on building and product lifecycle assessments, so we will be focusing on those particular credits. However, we wanted to make you aware that, depending on the information that the manufacturers are willing to share with you, a project team may also be eligible for the credits for sourcing of raw materials and material ingredients as well.
Hi everyone, my name is Liz Monet and I'll be picking up here on the business case for why we do LCAs. So why even do an LCA? The business case is different depending on if you are a manufacturer considering doing a product LCA or a project team considering doing a whole building LCA. As a manufacturer, an LCA helps you look at the environmental impacts of your supply chain. By looking at the different stages of products, such as the raw materials needed or the manufacturing process, for example, you can assess what the major contributors are and consider alternatives. Additionally, with the new LEED system going into place, you are also gaining a competitive advantage by becoming a product of choice for project teams. If many products in your industry are working on LCAs, you may also just be keeping up with your industry so that you don't get left behind. Now, as a project team, a whole building LCA helps you attain material and resource credits towards your LEED standing. Additionally, a whole building LCA helps you look at the materials you are using and allows you to consider alternatives as early as the design phase. Often, efficient and resilient materials used to help achieve this and other LEED credits can lead to lifetime energy and cost savings for the owner as well. Okay, Before we press on to conducting LCAs, let's take a moment to clarify the terminology we will be using throughout this course. Let's take a look at the process for completing a full product EPD for LEED credits, starting with the Product Category Rules, or PCRs. Product Category Rules are a standard set by the industry for a product type in order to conduct a more uniform and comparable EPD. To use a PCR, you'll need to find the PCR that is closest to your product, or if there is nothing similar to the product that you are trying to create an EPD for, you will have to look into having one made. The PCR helps determine things like the functional unit, which could be something like 1 square foot of carpet or 1 ton of concrete, as well as the scope that is covered, such as cradle to gate. Using the same functional unit and scope allows products to be better compared across a product category. Okay, let's think about functional units and how they may differ based on the products or systems we are trying to compare. In practice, PCRs tend to outline a specific product type, such as resilient flooring. But to get a better understanding of what functional units are and how they are created, we'll take a moment to think of functional units that may be best to compare these products. Looking at a paper bag versus a plastic bag, the functional unit could be one bag. It could also consider how much can be carried by the bag, or if the bag could be reused. Even in an easy example, we can see that determining the functional unit to compare can get complicated. When we look at a paper towel versus a hand dryer, we can see these are different systems entirely, although they have the same purpose. A paper towel is a relatively easy product to evaluate, though some people use multiple paper towels to dry their hands, which could cause some discrepancy. A hand dryer, however, is composed of the actual hand dryer, as well as the time and energy needed to dry your hands. The functional unit here could be considered a person drying their hands, or one hand drying. Similarly, we can look at a book versus an e-reader. The answer to this question may depend on how many books are actually on the e-reader and how efficient the e-reader is. Having one book on an e-reader versus a paperback hardly seems efficient, but having a library on an e-reader might save enough materials to make it the better option. Certainly, we can see making a fair and equal comparison can get a little bit tricky. Next, we can look at cars versus trains and how these may compare for your commute every day. Clearly, we can't compare a car and the materials needed to make a car to all of the materials for a train. So we'd want to look at some other factors like ridership. The energy and materials for a train would have to be divided by the number of riders to start to make a fair comparison against a car. In the case of buildings, the functional units we look at would be something more in line with these. For products, let's say we were comparing flooring options. So one functional unit could be 1 square foot of carpet that lasts for 10 years, so it has a 10-year lifetime, and we're looking at that from cradle to gate. We would want to compare that to something like, say, hardwood floor. We would also want to look at 1 square foot of hardwood for its lifetime from cradle to gate. Now, if the lifetime of hardwood is longer, then that factors into the overall environmental impacts as well, because we know that carpet would need to be replaced more frequently. Next, if we look at office buildings, our functional unit to compare maybe, say, 10,000 square feet of building over a 60-year lifetime, and we could look at that from cradle to grave. We would want to compare that to other similar buildings with a similar function and a similar lifetime over the same scope, cradle to grave. Now you might be saying, cradle to what? What is she talking about? Let's take a moment to refresh on what the life cycle scopes are. When we're looking at the scope of an LCA, we, or the PCR, needs to determine what is included in the analysis. There are different stages of a product's life, as shown. The raw materials production and distribution, product manufacturing, distribution and retail, the use phase, and disposal and recycling. Gate to gate only looks at the manufacturing of the material. Cradle to gate, for a manufacturer, would look at the raw materials and the manufacturing of a product. Cradle to grave also includes the material and the disposal. We often see cradle to gate and cradle to grave in these studies. We can also think of this similarly at a building scale, where many products would make up the raw materials. The manufacturing of the building would be the construction. The distribution would be getting the materials to the site. And the use phase could be composed of the maintenance and replacement of building features. And of course, the demolition would be the disposal phase, which would either go to landfill or for reuse. Additionally, some products and systems are trying to close the loop, as it's called, by looking at the cradle-to-cradle life cycle scope. Beyond cradle to grave, these products and systems are aiming to reuse materials, working towards making the product or system as close to waste-free as possible. In this way, they are trying to mimic ecosystems and make the best use of all of the products involved. Next, we'll look at the basics of conducting an LCA. The framework of an LCA begins with setting the goal and scope of the LCA. As we've talked about, the goal and scope is often set by the PCR. However, if no PCR is available, following ISO guidelines, you can also set a goal and scope of your own. After the goal and scope is set, we conduct the life cycle inventory, or LCI. Depending on what is involved in the scope of the LCA, we'll need to collect quantifiable data, such as, say, kilograms of limestone or gallons of water. And we will do this for all of the life stages in the analysis. Those stages may include raw materials, manufacturing, transport, use, and disposal. Next, we will move on to the Life Cycle Impact Assessment, or LCIA. After we have collected the inventory information, we run an environmental assessment. That will give us results such as climate change, eutrophication, human toxicity, ozone depletion, and more. This term, LCIA, is often used interchangeably with LCA. Lastly, we can look at the overall life cycle assessment to determine the environmental impacts of the whole product or system. This would be what is termed an LCA. It looks at all of the impacts weighted based on different methods to determine an overall score or an overall impact. The overall score is the impact on the environment. We would also like to take a moment to note a related term, life cycle cost, or LCC. A life cycle cost assessment looks at the monetary costs related to the lifetime of a product, process, or system. However, we will not be covering LCC in this course. The focus of this course, as well as the LEED credit, is on the environmental impacts. And therefore, we will look exclusively at the LCA and EPDs. Okay, now after the LCA has been completed, we can consider conducting and completing an EPD. An environmental product declaration, or an EPD, is a standardized way to quantify the environmental impact of a product or a system. The scope and format is standardized by the rules in the PCR for that product. The results of the EPD are based on the results of an LCA. Lastly, to be a completely compliant EPD for the LEED credit, the EPD must be third-party verified. To ensure the integrity of the EPD, a group that did not work on the LCA or the EPD must verify that the EPD was conducted according to the standards and the PCR. The third-party verification for the EPD of a product must be completed in order to count as a full product for the LEED credit calculation. Okay, we went over a number of terms and processes here, so let's take a moment to review what we've learned. We covered how LCAs relate to LEED credits. We also spoke about why a manufacturer or a project team should consider conducting an LCA. Lastly, we covered the basic terminology and the general process for conducting an LCA, whether it be a product or a building. Let's see what we remember with a couple of questions. What LEED V4 credit or credits are related to LCAs? The correct answer here is A for whole building LCAs and C for product LCAs. Why do an LCA? Please select all that apply. Conducting an LCA may help with B, C, and D directly. LCAs do not directly consider costs, though some applicable products may also reduce costs. In a cradle-to-gate LCA, which stage is not included? Cradle-to-gate assessments end once the product is quote-unquote out of the gate, which for a manufacturer would be at the end of the manufacturing process. The use phase is not included in this scope. For the EPD process, put these steps in order chronologically. For an EPD, first must come the PCR, second is the LCA, third is the EPD, and lastly is the third-party verification of the EPD. Thanks for your attention. Our next module will cover how to conduct and evaluate product LCAs, including a case study to follow along with.